Hi to everyone, welcome to my lectures video. Today we are going to talk about Fourier transform. Fourier transform. Fourier transform, before the definition of Fourier transform, what is mean by a transform? Transform is a device which changes one form to another form, which is easier to solve. Okay. For example, for Fourier transform of a function f of x is defined as Fourier transform of, that is capital F, of f of x. This is a given function f of x, which is nothing but 1 by root of 2 pi integral minus infinity to plus infinity f of x into e power isx dx. This integration with respect to x get the result in terms of s, that is our resultant function. Okay, that is the Fourier transform of the function f of x. This is the definition of Fourier transform, and next we are going to see about inverse Fourier transform. Now, what is the formula for inverse Fourier transform? That is f of x, which is equal to 1 divided by root of 2 pi integral minus infinity to plus infinity f of x, that is Fourier transform of the given function f of x into e power minus isx dx. This integration is with respect to s. This is inverse Fourier transform, and there is another formula which we are going to use it in the problem, which is Parseval's theorem or Parseval's identity. Parseval's theorem on Fourier transform. It's a formula, that is integral minus infinity to plus infinity f of x modulus the whole square dx, which is equal to integral minus infinity to plus infinity f of x, that is Fourier transform of f of x modulus the whole square ds. These are the very important formulas in Fourier transforms. Based on these formulas, we are going to discuss some problems using Fourier transforms. That's the first concept. Now we are going to discuss an important problem, okay, on Fourier transform. That's the first problem, that is find Fourier transform of the function f of x, which is defined as a square minus x square, whether a square minus x square is valid from modulus of x less than a. It is 0 when modulus of x greater than or equal to a, greater than a. For this function, we need to find the Fourier transform and hence deduce z. Integral 0 to infinity and integral 0 to infinity sin t minus t cos t divided by t cube the whole square dt, which is equal to pi by 15. So in this problem, we are going to find out a Fourier transform of the given function, and using that we have to deduce two parts. Okay, first part is integral 0 to infinity sin t minus t cos t by t cube, which is equal to pi by 4. The second part is integral 0 to infinity sin t minus t cos t divided by t cube the whole square dt equal to pi by 15. Okay, the first part, first we have to solve the first part. What's the first part of the problem? First we need to find the Fourier transform of the given function. Okay, what's the formula for Fourier transform? Fourier transform of f of x is by the definition of Fourier transform of f of x, that is f of x, which is equal to 1 by root of 2 pi integral minus infinity to plus infinity f of x into e power isx dx. By the definition of Fourier transform, can write like this. Okay, now we are going to apply the f of x here, but here our f of x given, f of x can be written as, given function can be written as a square minus x square and 0. So the value modulus of x less than a, which is nothing but, we can write it as modulus of x less than a can be written as minus a less than x less than plus a. The value of a, value of x lies between minus a to plus a. That's the meaning of modulus of x less than a. And what about the other cases? Modulus of x greater than, that is otherwise. All other cases can write it as otherwise. So remaining cases are the function's value of the function is 0. That is the given function. Okay. Now we can split the integration as minus infinity to plus infinity can be written as minus infinity to minus a and minus a to plus a and plus a to infinity. So overall minus infinity to minus a to plus a to infinity. Okay, in this range the function value is 0, minus infinity to minus a, because it comes under otherwise case. Minus a to plus a range, the function value is what? A square minus x square. And the other range a to infinity also comes from otherwise case, therefore the function value is 0. Now we can write it as 1 divided by root of 2 pi integral minus infinity to minus infinity to minus a, the function value is 0 here, plus integral minus a to plus a, the function value is a square minus x square e power isx plus, on the other case, integral a to infinity 0 into e power isx dx by the definition of the given function, which is nothing but 1 divided by root of 2 pi, the integral value is 0 here, it is also 0, we can write it as integral minus a to plus a square minus x square into e power isx. The formula for e power I theta is nothing but cos theta plus I sin theta. In the same sense, we can write it as cos sx plus I sin sx. By using the formula e power I theta as cos theta plus I sin theta formula. E power I theta can be written as cos theta plus I sin theta by using the formula into dx. Now we can split the integral to, that means 1 divided by root of 2 pi integral, this, there is a formula right, minus a to plus a square minus x square into cos Sx plus I into integral minus a to plus a square minus x square into sin Sx dx. Now, we know one formula, right? Integral minus constant to plus constant f of x dx. The value of the integration, definite integral minus k to plus k f of x, any function f of x can be written as, there are two types. In case if f of x is even function, if f of x is an even function, we can write it as 2 into integral 0 to k f of x dx. 0 if f of x is an odd function. If f of x is odd, then you can write the value of the integral is 0. If f of x is an even function, then the value of the integral is 2 times of integral 0 to k f of x dx. In the same sense here, cos x is an even function. Here cos x is an even function, we can consider it as plus symbol. Cos x is an even function, we consider it as plus symbol. A square, constant is always an even function. So this is an even function. X square, x, the power of x, the even powers of x are all even functions. So appa even function and even function. So addition or subtraction of even function again in even function. So this is also plus, even function into even function. Product of two even function, plus into plus is again plus. Plus into plus is again plus, therefore the total function, that integrand function becomes an even function. Okay. Whereas here sin Sx, sin theta is an odd function, we consider the symbol minus here. The odd function, consider for symbol minus for odd function. Okay. And a square minus x square again an even function, therefore consider the symbol 3 plus. So minus into plus, it becomes minus. So for even, it's an odd function. So for total is an even function here. Here product of two odd into even is an odd function. So a function is even, then we can write it as 1 divided by root of 2 pi. We can write it as 2 into integral, the integrand function, overall function is even. So for we can write it as 2 times of integral 0 to a square minus x square into cos Sx, cos Sx dx plus I into the this here for this second integral, the integral function is odd function. If it is an odd function, then the value of the integral is 0, minus constant plus constant f of x is 0. Here minus a to plus a, this is our f of x here. So answer is 0 here, I into 0. Okay. Now 1 divided by root 2 into root pi, this 2 can be written as root 2 into root 2. Now here product are two functions, okay, a square minus x was a function and cos is another function. Integral value of u dv formula, that means we have to write a formula here. I am going to here integral u v dx, u v dx. Now what is the formula for, is root 2 get cancelled. What is here, u equal to a square minus x square and v equal to cos Sx. To choosing u, we have to use the letters I late. I stands for inverse function, L stands for logarithmic function, A stands for algebraic function, T stands for trigonometric function and E stands for exponential function. Here first letter I late, there is no I inverse function, there is no inverse function here, tan inverse, cos inverse and there is no logarithmic function also. Therefore, the next letter LA, A stands for algebraic. Here the a square minus x square is an algebraic expression. So, we can take it as a square minus x square as u, and remaining are all take it as v. Okay. And we have to use a formula. What is the formula here? Integral u v dx can be written as u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4, etc., etc. It goes up to infinity by using the Bernoulli's formula. This is a Bernoulli's formula, integral u v dx, which is equal to the expression. Okay. Now u, what is u dash? U dash is it nothing but a square, the differentiation of constant is 0 minus 2x, and u double dash, again differentiation is 2, and u triple dash, differentiation again we get 0. Okay. Now v1, what is v1? Integral of one time integration of cos sx, which is nothing but integral cos sx dx, which is sin sx by s, integration with respect to x, sin sx by s. And again v2 is nothing but again integrating sin sx, by s with respect to x again. Now what is integration? Integral sin sx becomes minus cos sx divided by s square, and v3 is again integration of v2, integrating v2, we get integral minus cos sx divided by s square into dx, which is minus sin sx divided by s cube. Now we have to use the formula, use it in the formula. How to use it in the formula? The root to root cancel, we get which is equal to, that is f of x, which is equal to root of root 2 divided by root pi integral 0 to infinity. Now we have to apply the formula, Bernoulli's formula. What is the first function u? U is a square minus x square into v1. v1 is the integration value, that is sin sx by s. Next, minus u dash. What is u dash here? Minus 2x. Minus 2x into, and v2. What is v2 here? Minus cos sx by s square. Next, plus u double dash. What is u double dash? U double dash value is minus 2 into v3. What is v3 here? Minus sin sx divided by s cube, and u triple dash is 0 into anything 0, and etc. each and every again in differentiation, that is higher powers of, that is u triple dash, u4 dash, u5 dash, u6 dash are all 0. Therefore remaining terms become 0. This is the value of the integration, and we have to apply the limits. What are the limits here? 0 to a is the limit. Therefore 0 lower limit and upper limit, 0 to a. Now we are going to apply upper limit. This can be written as root of 2 by pi. While applying the upper limit, a square minus x square, we have to apply a for x, instead of x we have to apply a. Okay, a square minus a square becomes 0, and 0 into anything 0. And here, while minus into minus plus here, 2 into a, 2a sin sx, there we can write it as minus cos sa, minus cos sa divided by a square. And in the third step, plus 2 sin sa divided by s cube. This is a upper limit. Next, minus, we have to apply the lower limit. Lower limit we have to apply, instead of x we have to use 0, lower limit 0. Okay. If when applying the lower limit, sin sx, that is s into 0, sin 0 value is 0. So for 0 into anything 0 first. And the second, 2 times of x, 2 into 0 is 0, 0 into anything 0. The first second term is also 0. And the third term, while using x equal 0 here, sin 0 is 0. The third term is also 0 here. After that, we have to write here, here 2 is common, so we can write it as 2 into root of 2 by pi sin sa or as, sin as minus sin as by s cube. Here there is a minus a into cos as divided by s square. Now we can take LCM, like 2 into root of 2 by pi. What is LCM here? S cube is LCM. So the numerator becomes sin as minus as cos as divided by s cube. This is required Fourier transform of the given function f of x, which is the first part of the result. This is our first part of the result. So, first part, what's the first part here? Find Fourier transform of the given function. This is the Fourier transform of the given function. 2 into root of 2 by pi sin as minus as cos as divided by s cube. That's the first part of the result over. Next, we need to find the deduction part. There are 2 deduction parts. We need to prove 2 parts. Okay, one by one we are going to see. Now we are going to prove the first deduction part. What's the first deduction part? Here in the first deduction there is no square term, so we can write the inverse Fourier transform for the first part of the proof. Okay. Here the second proof, there is a square, the function square. Here to prove we have to use the Parseval's theorem, that is Parseval's identity. That's the third formula already given. Okay. So to proving the first deduction part 1, deduce the first part by using inverse Fourier transform by using the formula inverse Fourier transform of f of x, we get the formula is f of x which is equal to 1 divided by root of 2 pi integral minus infinity to plus infinity f of x, that is Fourier transform of the function, into e power minus isx ds. This is the inverse Fourier transform of f of x, that is f of x equal to, this is our transform of the given function, and e power isx dx. Now we have to use this. What is 1 divided by root of 2 pi integral minus infinity to plus infinity? What is the Fourier transform of the given function, which is nothing but 2 into root of 2 by pi sin as minus as cos as divided by s cube. This is the first part of the proof, that is Fourier transform of the given function into e power minus isx ds. So using this formula, we can find the first answer, that is first deduction part. Okay. Now listen, here we can write it as 1 divided by root 2 into root pi. So the constant becomes root 2 divided by root pi. The root 2 get cancelled, and integral minus infinity to plus infinity. This integral, that means sin as minus as cos as divided by s cube into this e power minus isx can be written as e power minus I theta formula. E power plus I theta becomes cos theta plus I sin theta. E power minus I theta becomes cos theta minus I sin theta. So you can write it as cos, instead of theta we have xs, that is cos sx minus I sin sx. This is a formula for e power minus I theta into ds. Now we can use, right, you can write it as 2 divided by root pi into root pi becomes plus pi, that is integral. We can split this as two part. The first part, with the first part we can write it as integral minus infinity to plus infinity sin as minus as cos as divided by s cube into the first one cos sx dx, and we can split the second part as minus I into integral sin as minus as cos as divided by s cube into sin sx ds. Why we are splitting like this? Without using the integration part, we can find the value by using even or odd concepts of definite integrals. Okay, here we know already. You have to use the formula, that is this is cos sx becomes positive, that is even function. Cos sx is an even function. Cos theta is an even function. So cos sx is an even function. We can write the symbol plus. Here sin sx is an odd function. Therefore we can use the symbol minus here, and cos sx minus s power 1. So variable power 1 becomes an odd function, therefore minus, and cos sx cos as is a even function. So that's a numerator. Here s cube is a odd function, s power 3, s power variable power odd number is an odd function. Therefore s power odd number 3 becomes an odd function. Now the total function becomes minus into minus plus. So our numerator becomes a minus. Now denominator is also minus. Minus means odd function. Okay. Upon numerator denominator we can cancel. Then it becomes a plus 1. So plus into plus. Again here is a plus part. The whole thing becomes plus. So this function is a even function, and again here is also even function, even into even, that is plus into plus, again plus. Therefore it is an even function. The total, the whole function becomes, integrand function becomes even function. Whereas in the next integration, this is an odd function, we can write it as minus, the whole thing becomes a even function. Therefore this becomes even function. So even into odd, that is plus into minus becomes a minus. So the whole part of the second integration, integrand function becomes a odd function. Already we know a formula that integral minus constant to plus constant f of x dx, which is equal to 2 times of integral 0 to that constant f of x dx, if this is true if f of x is even function. If f of x even function, this is valid. Otherwise, if it is an odd function, the integral value of the integral is what? 0. It's an odd function. If it is an odd function, if it is odd, now the value of the integral is 0. Now we have to apply here, that is 2 by pi integral minus infinity to plus infinity. Okay, we can write it as, because the integrand function is an even function, so we can write 2 times of 0 to infinity. So consider the infinity as constant here. Okay, minus infinity plus infinity, minus k to plus k, upon 2 into 0 to infinity, this function again, that is sin as minus as cos as divided by s cube into cos sx ds minus I into the integrand function here, odd function. The whole function, what? The second integration, the whole function becomes an odd function. Therefore, for odd function minus constant to plus constant form, the integral value is 0. So the whole value becomes 0 here. So without integrating, we get the value by using the formula. Now you can write it as 4 divided by pi, 4 by pi. Okay, integral 0 to infinity sin as minus as cos as divided by s cube into cos sx ds. What is the right hand side here? F of x, that is a given function f of x. What is the given function f of x? A square minus x square, that is a given function. So we can write it as a square minus x square. Now we are going to prove the part integral 0 to infinity sin t minus t cos t divided by t cube, which is equal to pi by 4. Here is also we get the same expression like sin as. So this integration with respect to t, so we can substitute here, instead of here there is a s cube part, here there is a t cube part. So we can use the substitution as, we have to use the substitution as, here there is an s cube and we have to prove in terms of t cube. So we have to apply, we have to put t equal to, put s equal to t. So the answer in terms of x, so we need to apply, instead of s we can t. Okay, and there is no part here, sin t minus, here consider the first part, sin as. So here we are substituting s equal to t here, therefore it becomes sin at, but we have to prove sin t. Okay, for cancelling this a, we can take a as 1, a equal to 1, and a equal to 1, s equal to t, that is at, that is 1 into t, cos a value 1, s value t, and there is no, it should be vanish, or it should be 1, then only we can get the result. Then how to write it as 1 here? By using the substitution. What is the substitution here? Instead of x we can apply x equal to 0. Why we are using the substitution x equal to 0? Because cos 0 value becomes 1, cos 0 is 1, so that we are using the substitution x equal to 0. Okay, while using those substitution, what do you get? a square, that is 1 square minus x square 0 square, which is equal to 1, that is 4 divided by pi, 4 divided by pi, and sin as, sin integral 0 to infinity sin a value 1, s value t, that is sin a t, that is sin as becomes sin t minus a value 1, s value t. So 1 into t, t cos s as, a value 1, s value t. So you can write it as cos t divided by what's the value of s? So we have to apply s equal to t, therefore it becomes t cube into cos 0, cos 0 value 1 into what about ds? ds becomes dt. So we have to use dt here. We have to use dt. Cos 0 value 1, this is 1, 4 by pi integral 0 to infinity sin t minus t cos t divided by t cube into 1 dt. Our aim is to prove this implies integral 0 to infinity sin t minus t cos t divided by t cube value of dt, which is equal to, I can write this pi goes to the left hand side means pi by 4, which is, this is the first part of the deduction. See here, integral 0 to infinity sin t minus t cos t divided by t cube equal to pi by 4. Hence, we proved the first part of the deduction, hence the result, first part. Now, we are going to prove the second part of the problem, deduction part. Okay. Now, we are going to prove the second part of the deduction, that is the deduction part 2. Deduction part 2. Here, in this deduction part, we have square or power 4, more than 2 powers, even powers, that is square or 4. Then we have to use the formula Bernoulli's Parseval's identity, or we can call it as Parseval's theorem. Using Parseval's identity, using Parseval's identity for Fourier transform, by using the Parseval's identity for Fourier transform. What is the Parseval's identity of Fourier transform? Integral 0 to infinity f of x modulus the whole square ds. This is nothing but a Fourier transform. Okay, Fourier transform with respect to s. Okay, which is equal to integral 0 to infinity f of x modulus whole square dx. This is a Parseval's identity of the Fourier transform. Okay. Now we have to use the values of f of x and f of x here. We can get the second part of the deduction. Now you can see integral 0 to infinity. What is f of x? Fourier transform of the function. In the first result, it becomes 2 into root of 2 by pi sin as minus as cos as divided by s cube. This is the Fourier transform of the given function, the whole square, modulus the whole square. Okay, that is the modulus whole square ds, which is equal to modulus of f of x the whole square, which is integral 0 to infinity. Here, instead of integral 0 to infinity, it is valid for we can apply the possibles as integral minus infinity to plus infinity 2. Also we can write it as minus infinity to plus infinity. So 2 times of integral 0 to infinity. Instead of minus infinity plus infinity, this f of x is defined for minus a to plus a. This is the value of this is minus a less than x less than plus a. The otherwise, all other cases become 0. So we can write it as instead of minus infinity plus infinity, we can write 2 times of integral 0 to a, okay, because the function is defined for minus a to plus a. If it is minus a to plus a means it's an even function, so for 2 times of integral 0 to a. So this is a square minus x square the whole square modulus the whole square ds. This 2 and this 2 get cancelled, and here 2 times root of 2 pi pi integral 0 to infinity sin as minus as cos as divided by s cube the whole square ds, which is equal to the value integral 0 to a. What is the value of a square minus x square the whole square, that is a minus b whole square formula, that is a power 4 minus 2 times of a square x square plus x power 4. This is a formula for a minus b whole square. By using the formula a minus b whole square we get. And here is a square, so we can write it as, while applying square here 2 square becomes 4, and this root of 2 by pi becomes 2 by pi squaring, okay, while squaring we get like this, okay. So 8 by pi integral 0 to infinity sin as minus as cos as divided by s cube the whole square ds, which is equal to, while integrating with respect to x, what you get, a power 4 into x minus 2 times of a square into x cube by 3 plus x power 5 by 5 x power 5 by 5. Apply the upper and lower limit 0 to a, okay. Now which can be written as a power, while applying the upper limit we can get a power 5 here, and 2 by 3 into a square into a cube is again a power 5 plus a power 5 by 5. This is upper limit minus lower limit. How to write the lower limit? 0. While applying 0, we get 0 minus 0 plus 0, all becomes 0. And we can write it as a power 5 common, then 1 minus 1 by 3 plus 1 by 5. So remaining of 0. And a power 5 into, what do you get? We are taking LCM 15 as, it becomes 5 minus, that is 15 minus 5 plus 3. So what do you get? Then here it is 2. So this becomes 10. 8 by 15. So what do you get? So left hand side 8 by pi integral 0 to infinity sin as minus as cos as divided by s cube the whole square ds becomes a power 5 into 8 by 15. See, the 8 and the 8 get cancelled. We can write the integral 0 to infinity sin as minus as cos as divided by s cube the whole square ds, which is equal to a power 5 into pi by 15, a power 5 into pi by 15. But get the result, to prove the result we need t power 3 the whole square. So instead of t power 3 we have s cube, okay, instead of t cube we have s cube. So we can use the substitution, put s equal to t. So yeah, the variable s is a dummy, we can use s as t, okay. Now this becomes ds as dt, and there is no a power 5, so we can put a as 1, because we are going to prove sin t here, sin a into s, that is a sin a t, okay. Instead of a we can put t, means we get this deduction part, so that applying a equal to, and what do you get? Integral 0 to infinity sin a into s, a value 1, s value t, therefore it becomes sin t minus a value 1, s value t, it becomes t cos a into t cos t divided by s cube becomes t cube the whole square ds becomes dt, which is equal to a power 5 value 1 into pi by 15, a value 1, so it becomes pi by 15. Hence we proved the part 2. Hence the deduction, part 2 deduction over. So here this is a very important problem. So first part is we have to find the Fourier transform of the given function. Second part, using that Fourier transform and the given function, we have to prove the first part of the deduction by using inverse Fourier transform formula, and the second part of the deduction has the square or power 4, means we have to use the Parseval's identity to prove the second part. Hence we proved the second part of the problem also, okay. Hence the problem next we are going to discuss another important problem, very important problem in engineering. To prove the second problem. Now in second problem, find the Fourier transform of the function f of x equal to 1 modulus of x less than 1, modulus of x greater than 1, otherwise 0, okay, and hence deduce integral 0 to infinity sin t by t dt, which is equal to pi by 2, and another part integral 0 to infinity sin t by t the whole square, that is sin square t divided by t square dt is equal to pi by 2. Now consider the problem. This is also very important, and how to solve this, how to prove. Solution. Here is also there are three parts of the problem. The first part becomes we need to find the Fourier transform of the given function. The second and third part becomes the deduction using the Fourier transform of the given function. Okay. Now again we are going to use the Fourier transform formula here using Fourier transform of f of x. By definition of Fourier transform. Using Fourier transform of f of x, or by using definition of Fourier transform, by definition of Fourier transform. By the definition of Fourier transform of f of x. What's the definition? Fourier transform of the given function f of s, which is equal to 1 by root of 2 pi integral minus infinity to plus infinity f of x into e power isx dx. E power isx dx. This is a Fourier transform of a given function. Now f of x. Now here the function is 1 divided by root of 2 pi integral. What is the given function? The given function defined for, this is minus infinity to plus infinity. Here the given function can be written as, instead of modulus of x less than 1, we can write it as minus 1 less than x less than plus 1. Both are same meaning. Okay. Like say in this last problem, modulus of x less than a means minus a less than x less than plus a. Here instead of a we have 1. So for minus 1 less than or x less than or 1. Okay. So this is the other case. All other cases the value of the function becomes 0. So we can split this function as, okay, minus 1 to plus 1. Instead of minus 1 to plus 1, the function value is what? 1. So we can write 1 here. This is our function value f. And all other cases, otherwise cases, the function value is what? 0. Okay. This is the definition of the given function. So we can write the function as f of x as 1, 0, okay, minus 1 less than x less than plus 1 otherwise. So we can write the given function like this, minus 1 to plus 1, because modulus of x less than 1 means minus 1 less than x less than plus 1. Okay, that is the definition. By the given function we can write like this. Here we have to use minus infinity to plus infinity. We can split the integration as minus infinity to minus 1. The function value is what? The function value is 0. So for 0 into anything 0, 0 into e power isx dx plus integral, the second part minus 1 to plus 1, that is minus 1 to plus 1. The f of x value is what? What's f of x in the range? 1 into e power isx dx plus integral 1 to infinity, the function value is what? 0. 0 into e power isx dx. So we can write it as integral root of 2 pi, 1 by root of 2 pi. The integral value is 0. 0 into anything 0, therefore 0. And here integral minus 1 to plus 1 e power ixx can be written as integral minus 1 to plus 1. The value of e power isx, e power I theta formula, that is cos sx plus I sin sx. Cos theta plus I sin theta, that is a formula actually, into dx. The third part also 0, because 0 into anything 0. Next, 1 divided by root of 2 pi. Now we can split this as two parts. This is an even function, it is an odd function. See, minus constant to plus constant, if it is an even function, or 2 times of 0 to k f of x dx. So if this is an even function, we can write it as 2 times of integral 0 to 1 cos sx or else we can use another step also. So we can write it as integral -1 to +1 cos Sx dx plus I into integral -1 to +1 sin Sx dx. This is an even function, it is an odd function. We can write it as 1 divided by root of 2 pi. If it is an even function, integrand function is an even function, then we can write it as 2 into integral 0 to that constant. Constant is 1 here. Okay, it's cos Sx dx plus I into the value of the integral 0, because the integrand function becomes a odd function, therefore it becomes 0. Value of the integral is 0 by using that formula. Now we can write it as 1 divided by root 2 into root pi. This 2 can be written as root 2 into root 2. Okay, and the root 2 get cancelled. And what is the integral of cos Sx? Becomes sin Sx divided by s. Apply the upper and lower limit 0 to 1. So what you get? 2 by pi root of 2 by pi sin s by s minus sin 0 by s. So what you get? Hence Fourier transform of f of x, which is equal to root of 2 by pi sin s by s, and sin 0 value is 0, therefore this is 0. So Fourier transform of f of x is equal to root of 2 by pi sin s divided by s. This is the first part of the problem. So what's the first part? The first part is we have to find the Fourier transform of the given function. That is the Fourier transform. That is root of 2 by pi sin s by s is our Fourier transform of the given function. Next, we have to prove the deduction parts. First deduction. First we have to prove the first deduction. Part 1. To prove the first part of the deduction, here the first part, see the first parts integral 0 to infinity sin t by t, which is equal to pi by 2. Okay, now there is no square or even powers, okay, in the whole function. Therefore we can use the formula inverse Fourier transform, using inverse Fourier transform using the inverse Fourier transform formula. What do you get? F of x equal to 1 divided by root of 2 pi integral minus infinity to plus infinity f of x into e power minus isx ds. This is the inverse Fourier transform formula. In this formula we have to apply the Fourier transform value, that is, this is nothing but 1 by root of 2 pi integral minus infinity to plus infinity. What is the Fourier transform? The first part of the proof, okay, which is nothing but root of 2 by pi sin s divided by s into e power minus isx ds. Okay, we are just applying the Fourier transform of the given function. Next, 1 divided by this root of 2 pi can be written as root 2 into root pi, and this root of 2 pi can be written as root 2 divided by root pi. After that, integral minus infinity to plus infinity sin s divided by s. This e power minus sin theta formula, cos theta minus I sin theta, that is a formula for e power minus I theta. So, instead of theta we have sx, therefore formula for e power isx is cos sx minus I sin sx into ds. Here root 2 get cancel, 1 by pi into root pi becomes pi. 1 by pi into integral minus infinity to plus infinity sin s divided by s into cos sx ds minus integral minus infinity to plus infinity I times I into sin s ordinary product sin s by s into sin sx ds. So, now we have to integrate, okay. Well, before the integration we need to check whether is a possibility to apply even or odd concept, like cos theta, this is a function of s, is a s, cos s is a always, cos theta is always an even function, therefore we can write it as plus here. What about sin s by s? Sin s is, sin theta is always an odd function, so for minus and divided by variable power 1 is a odd function. Therefore, we have to use the symbol minus. For odd function we have to use the symbol minus, for even function we have to use the symbol plus. So, here minus into minus divided by minus becomes, cancelling, this becomes plus, this becomes plus. So, the whole this becomes plus function. So, this is plus into plus, plus into plus becomes plus. So, even into even becomes even function. So, the integrand function becomes a even function. If it is an even function now, we can write it as 1 by pi into 2 into integral 0 to infinity sin s by s cos sx ds minus I into. Now, come to the second part of the integration. Here sin x is an, sin theta is always an odd function, so we have to use the symbol minus, and sin s by s, that is here we discussed already, plus. So, plus into minus becomes minus. So, it's a whole, the whole function becomes an odd function. Therefore, integration of odd function from minus constant to plus constant becomes 0. So, we can write it as 2 by pi integral 0 to infinity sin s by s cos sx dx ds. Here what is f of x given? 1. Okay. How to prove the first part of the problem? To prove the first part of the problem, we have s here, whereas here t. Therefore, we have to use the substitution, put s equal to t, then ds becomes dt, and there is no such term here cos sx. So, to become to change it as 1 means we have to apply x equal to 0, because cos 0 value is 1. So, we have to use the substitution x equal to 0. Where x equal to 0, this becomes cos 0, therefore, this becomes 1. So, 1 equal to integral, 1 equal to 2 by pi integral 0 to infinity sin t divided by t into cos 0 into dt, because cos x equal to 0, therefore cos 0 equal to t. So, we get 1 equal to 2 by pi integral 0 to infinity sin t by t dt, therefore, integral 0 to infinity sin t by t, it comes to the left hand side, means we get pi by 2. This is a second part of the deduction, first part of the deduction, okay. And how to prove the second part of the deduction? By using Parseval's identity, we can use Parseval's identity, we can prove the second part of the deduction. How to use Parseval's identity? To prove the second part of the deduction using Parseval's identity. Of Fourier transform. What's the Parseval's identity of Fourier transform? Integral 0 to infinity f of x whole square ds, which is equal to integral 0 to infinity f of x modulus whole square dx. Now integral 0 to infinity, what is the Fourier transform? 2 by pi root of 2 by pi sin s by s the whole square ds, which is equal to integral 0 to here the function defined for -1 to +1, therefore we can write it as 0 to 1, the function value is 1, therefore whole square dx. Now while squaring we get integral 0 to infinity 2 by pi sin s by s the whole square ds, it is equal to 1 square becomes 1 integral dx 0 to 1. So what do you get? 2 by pi into integral 0 to infinity sin s by s the whole square ds, which is equal to, what's the integral dx? X 0 to 1. So we get 1 minus 0, which is equal to 1, that is 2 by pi integral 0 to infinity sin s by s the whole square ds becomes 1. Now our aim is to prove that the given part, that is in the given part, see in the given part sin t by t the whole square, whereas here instead of t we have s, so we have to use the substitution s equal to t, therefore ds equal to dt. So what you get? 2 by pi integral 0 to infinity sin t divided by d sin t divided by t the whole square into dt equal to 1. Therefore integral 0 to infinity sin t divided by t the whole square dt, which is equal to, it goes to the right hand side, means it becomes pi by 2. That is the required result. Hence the second part of the deduction. So hence part 2. Here today we seen two problems, very important problems on Fourier transform. So finding Fourier transform and hence using that Fourier transform, using inverse Fourier transform and Parseval's identity, we can prove the results of the required deductions. Okay, these are the answers. Thank you.